The scoring on the
Oh, hey, I'm not here at that point.
Okay, evening everyone. Myself Sourabh and I have my colleague Jain with me. Today we'll be talking about event-driven architecture, and then we'll be looking at what are the different AWS services which are going to help you out in creating an event-driven architecture like EventBridge and StepFunction. Before starting, I'd just like to introduce myself, and then I'd like Jonathan to introduce himself. So myself, Sourabh, I am a solution architect at AWS. I support Greenfield territory, mostly the Georgia territory and some of the manufacturing customers. So that's brief about me. I'll let Jonathan introduce himself.
Hello, my name is Jonathan Johnson. I'm a solutions architect. Been with AWS about 1.5 years. Prior to that, I was a cloud architect for a number of years. Prior to that, some application development and architecture. So yeah, work on the Greenfield side of the business as well.
So thanks, Jonathan. So just to look at the agenda, what we'll be covering today, we'll be talking a little bit about challenges with distributed systems. And we'll be looking at event-driven architecture, how EventBridge can help you out in creating an event-driven architecture. Then we'll be looking at serverless orchestration. And last but not the least, a small demo of StepFunction with ID verification. So that's a brief agenda for today. Let me start. Like, you all have been heard about monolith and microservice. So monolith is basically all of the component of application running together. No service based. If one thing fails, everything fails, system fails, right? Then we moved on to the architecture called microservices. So we broke our software, our systems around different services, but we're still making the API based call. So that basically an API driven microservice based architecture, right? So you have one system calling to another services and waiting for the response, or in some scenario, a synchronous based response. But so let's take up this simple scenario is I have a client which is making a order creation and then it's going to invoice service, happy path, right? Invoice service replies back, yeah, I'm good. I've created the invoice. It goes back to client, everything well, right? It works well in this scenario, in this path. What happens now? I have an order service which goes to invoice, which goes to fulfillment, which goes to forecasting. This only completes once all of those completes, right? So that's an API-driven approach. Now, what happens if any of them fails? Everything or whole system fails, then it's hard for recovery, right? So we broke this system into other pieces. Let's say we say, hey, you want to have another way like order service, payment, fulfillment, shipping, and then make an API call here. But what happens if one system fails, which is basically I failed, like fulfillment is failed. Now what's going to happen? It's have to call shipping back. It's have to call invoice services back. It has to call payment back, all of those things, right? So it's basically waiting for another service, and whole system is still, we call it as microservice-based architecture, but still interdependent on each other to basically tell like, hey, once you get finished, let me know, I'll complete my task, or I'll get finished. Like in case of failure, it's very hard to backtrack where we are going, correct? So that's the challenge we are facing with the microservice API-driven approach, correct? Now, what happens? The another challenge we are facing here is if you want to add a new service or if you want to remove any service, right? So that's also there's a challenge in case of an API-driven approach is how we want to add a service or how are we going to remove the service from whole system. So what's the solution to it? Solution to it is event-driven architecture. I'll let Jonathan take it from here and walk you through some of the event-driven pieces here.
Sure. So what is an event-driven architecture? What is an event? So what we define it as a signal that system state has changed. And just a quick digression here. This is pretty intro level stuff. If you guys have follow-ups, we're more than happy to take that offline and kind of work through specific use cases or whatever, if you guys are interested in that. So an event is a signal that a system state has changed, and how can we use that? A little more definition on what is an event. It's asynchronous. So on the left side is sort of the diagram that Sourabh previously showed with that order processing example. There's some, even though it may on the surface look like it was loosely coupled, in fact, there was very hard dependencies on the order service, sort of coordinating, adding that additional service, the reward service and those fulfillment services, et cetera. So event-based architectures rely on more of an asynchronous model, the right side of the screen. You connect to service A, it generates a response, but service A then connects to service B in this example, and can handle processing, downstream failures, et cetera, and bubble that event notification back to the client. So let's look at how could we re-architect this order service. So in this example, instead of tying or calling each individual API, as was previously shown, what we're showing here is with an event-based architecture, you just state or issue an event, an order was created, then the relevant services that need to deal with that can listen in on that and take action. So how does that actually work? With an event bus. So here we have this concept of an event bus. We publish a message to it. There's some routing, filtering rules, and then that other systems can then take action based on whatever the actual event is. And we'll look into an example of what does an event look like. Animation is out. So AWS has a service called EventBridge, and that is our event bus. So it allows you to essentially do what we're talking about, send in an event, and then take action based on that.
Can I get who's ever sharing to stop the share real quick and restart it? Somebody online saying it's stuck. So,
Yeah, sure.
just try starting it over again. Let's see if that fixes it.
Maybe possible because I was sharing.
Share the whole screen or something. Okay.
What now?
Cool. So this is just a little bit built out example. Different services taking action on, in this case, orders coming in, right? So orders are placed in, and then the different systems that need to take action can do that. And it's not, and in this example, you're not sort of dependent on the ordering service team to implement each one of these things. All they do is punch a message into the event router, and then consumers that need to deal with that order event will add a rule to the event bus and then take further action on that. That's a little diagram about EventBridge itself. So what we were sort of talking about is in the middle, a custom event bus. That's where your applications can sort of send in the events and then create rules, and then downstream systems can then act on those messages. The other piece to EventBridge are built-in Sas integrations. So a lot of different third-party services can publish directly into EventBridge. And the other interesting thing about EventBridge is it does have what we're talking about thus far has been, sending in events and then taking action on those. There is a sort of a built-in scheduler that uses cron rules. So it's not, so if you needed to run a function or something on the right on a fixed schedule, that is a capability of EventBridge. And then, so what does an event look like? Well, as you probably guessed, it's just basically a JSON object, although this looks like the definition of a rule is in YAML in the middle. Whoops. Sorry.
So, I mean, if you take a look at EventBridge, it consists of three components. One is your target. Next one is your, not target, the source, where the event is coming from. The next one is your route, how you're driving that event. Like in case of order, the event is coming from the order system. Now you have multiple routes which can drive that event to, like A shipping can take it, an invoice system can take it, a fulfillment can take it. Different systems can take that event. And then the last one is the target, correct? So 3 components consist of an event bridge. Now in that, you can have multiple sources. It could be AWS sources, or it could be your HTTP endpoint, like you're calling from some third-party system and then pushing the events into event bus and then calling the respective target system. Similar with the target, you can have AWS services. Maybe you are pushing the data into S3, or you're calling a Lambda function, or you're calling a StepFunction, or you may be pushing the data into DynamoDB, right? So that's how you call the target, and that goes into the event goes into the target. That's 3 basic component of the event bridge.
Thanks. Awesome. So now I think we're going to sort of segue over to step functions. This slide sort of talks about, choreography through EventBridge versus orchestration through step functions. Kind of what are the differences there? So I'm not going to read all the bullet points, but that'll help sort of conceptualize one of the other. Are you taking over step function?
Yeah, sure.
Okay.
So I'll just push more on this slide. So we have 2 concepts called orchestration and one is choreography. So orchestration is basically you have a centralized control, which is basically controlling all of your multiple services together. So let's take a scenario. You have one application which can consist of multiple parts. It consists of Lambda function. It consists of DynamoDB. It consists of let's say an SDK, right? 3 pieces. Now all of this are controlled using one application, which is step function, correct? So that's an orchestration. Everything is driven from one place. Now choreography is basically you're just sending an event, and then all other systems are working interdependently, like they don't have dependency on each other, and they are taking the action by themselves. So that's basically choreography. Like not a centralized control, you just throwing an event, and then that's been basically controlled by all other systems or no dependency on each other, basically. So that's the choreography. So let's move on to step function. The step function is basically one of our orchestration engine, which is you can create a whole application, or you can run your whole application from one place and control it like the way you want to control it. So let's take a scenario of here. We talk about the bank application, like how it works on a bank. So you go to bank, you start your application by verifying the identity documents. Then you check address. You have your human review documents. The documents have been reviewed. You wait for the review, and then the approve application and the end, right? That's how your whole. If you go to bank, open an account, this all it works, right? Now, you may be thinking like, what else? There could be some parallel state, like verifying document and checking address could be done in parallel, right? That's how you do it. You can make a parallel state here. You can run things in parallel in step function. It's like do one task first and do another task in parallel. Once those are done, then do a human review, wait for review approve application, and then end. Same thing here. You may want to do this like wait for a review in a human approve before going to approve application, right? So you can basically code that in the step function is like, hey, wait until unless this is approved, then take the next action. I'm going to show you a lot of this stuff in the demo, but just want to give you a high-level idea what a step function can do and what are its capabilities from that perspective. Now, similarly, we want to basically have an approve application, review, approve, reject application kind of scenario, right? So you can basically you can constitute everything, all of this in a step function here. The same thing, it's going to move ahead. So this whole thing, what you are seeing here in a step function terminology is called a state machine. The state machine is basically you are running a whole application with multiple tasks together, and each of the tasks can run in parallel or it can run in sequential way, and it can have various choices or everything of that kind, right? So that's basically a state machine. If you look at a state machine, it's a collection of discrete tasks, which is states. So in the AWS scenario, it could be a Lambda function, it could be a SDK, or it could be a DynamoDB, anything, right? Depending upon your need. Now, when you transition those state machines, those are like custom rules. Like you're transitioning like, hey, if this happens, move to this. If this happens, move to this. If this doesn't happen, don't do anything. Stop here. Or in our scenario here, we say, hey, if review doesn't get approved, reject an application, right? So basically, you're writing a workflow by constituting different state machine, different tasks. That's called a state machine. That's a brief definition of state machine, and the whole thing which we were seeing now is called a step function. So what is a step function? Step function is a fully managed state machine, which you can help to basically orchestrate your whole all application component together and create one centralized location which is controlling all of those together, right? Now it's a managed service. You don't have to basically control anything underlying like, hey, what's running underneath. You just go and create your step function. It manages everything for you underneath. You don't have to worry about like scalability or availability. It can scale as much as you want. It's highly available, like it's a managed service and serverless. So that's basic about state machine. It consists of various, I would say, benefits. So it has a visual tool, which I will be walking in the demo, is like how you create it visually. Just a drag and drop. It's a low code, no code platform. You can even write your own code using state language, which is called Amazon State Language, ASL. But mostly it's a visual interface, drag and drop. You can drag and drop. You can even do it with a CDK or CloudFormation if you want to build it. It has built-in error capability. So let's take a simple scenario. In this bank application, I'll go back here again. This verify identity document is basically a Lambda function, right? So that Lambda function fails due to some reasons. Now this step function has an inbuilt capability where you can write like, hey, try 3 times, or if you find an error, do this, catch error. You don't have to write that inside Lambda function. It automatically handles for you. So that's one of the benefits. Another is service integration. So it has more than 200 plus service integration with AWS, with third-party systems. You can write your own custom integration there using Lambda function or different AWS services. Like you can even call an EC2 machine here using an HTTP endpoint here. That's visible here. Just the benefits I already mentioned, right? Less code, you can build application quickly, and resiliency, like it's a managed service. You don't have to manage anything underlying. Everything is managed by AWS. And at the same time, you also get the error-based capabilities. So you can do inbuilt error into it and all of those things, correct? Anything you want to add, Jonathan, here?
I think we may have mentioned this earlier, but step functions can be a target of EventBridge. So an event comes in, EventBridge can have multiple different consumers, if you will, but step functions can be one of them. And the other thing is, I think step functions, one of the benefits is instead of trying to bake all that logic into one or a couple of Lambda functions, and then, you know, a crazy amount of like if conditions or whatever inside Lambda, you can just use this tool to handle some of the exceptions and other workflow paths, right? Sort of out of the box with step functions.
Okay, that's great. So these are some of the use cases. So we have typically seen step function being used in data processing. So let's take a scenario. You have a data pipeline kind of task where you are entering the data and pushing the data into S3, then calling a glue job. That glue job basically pushing the data into maybe Redshift, or it's doing another transformation. You want to write a Lambda function to do it, right? So we have seen people using step function to create the whole data pipeline end to end. And I think you are in data space, so you may have encountered this before, right?
Not with this one. No, I'm more playing the analytics side of things. So
Okay.
the data engineering side, not so much.
So another use case is security automation. So the best example here is incident response. So let's take a scenario. If you have any incident in your security hub, so let's say your EC2 instance has been compromised, or it's been detected by any third-party threat intelligence service, like, hey, the IP has been compromised, right? You can use step function to basically automate the whole process of it. Like, hey, terminate the EC2 instance, remove it from security group, create a forensic instance for my analysis or anything, right? So everything you're creating at one place and just calling the SDKs. You're not writing much code. And we'll be taking a look at in demo how we do that. Machine learning is another use case where we have seen step function being used heavily. Is if you want to create a whole machine learning end-to-end pipeline from pushing the data to running a SageMaker model and then generating the endpoint, machine learning endpoint, then we have seen people using step function to do this whole pipeline. So imagine if you want to write that whole in a Python-based code or it's going to take a whole lot of work, right? Because step functions helps you in solve that problem, breaking that into silos or breaking that into individual pieces, and then writing code there. Microservice-based orchestration, we've been talking about order creation. We have seen a lot of use cases where simply e-commerce website, you create an order, you push to fulfillment, shipment, invoice service, all been done through microservice orchestration here. Anything else, Jonathan? Okay.
You got it.
So next is, as I was mentioning, it's a drag and drop tool. At the same time, you also get the way if you want to write using Amazon state language, it's a JSON-based language where you can write state machines. And I'm going to walking you detail into the demo next, so I'm not going to be getting into this much. Now, there are different patterns or integration patterns which we see with the step function. The first one we see is the request and response. Is like a simple sequential flow. You start a step, someone calls a step function, it does a task, and it responds back to that event. So simple request and response. Another we have seen extensively using, and I'm working with Delta on one of this, is they are started using step functions to basically running jobs now or scheduling the jobs. So as Jonathan mentioned in EventBridge, right, you can use EventBridge to schedule the jobs. So what people are doing now is they use EventBridge to create a cron job. And then in that cron job, they call step function, takes the response of the job, it gets finished or it started or it failed, and then respond back using EventBridge back to the event bus so that the concern system takes the input or output of it and respond appropriately to it. So we have seen people using step function and combination of EventBridge to basically run jobs or schedule jobs. Another one is wait for callback, which we have seen before, like in case if you have required a human approval or if you're waiting for some system to respond, then you use the pattern called wait for callback here. So those are the three patterns here of the step function. Now there are two kinds of workflows in step function. One is a standard workflow, another is an express workflow. You want to take this?
Sure. Why don't you take it? Because I don't know all the details.
Yeah, sure. So you have two kinds of workflows in step function. One is a standard workflow. Standard workflow is basically if your job or if your task takes longer than, I would say 5 minutes, or it doesn't require too many invocation at the same time, then you use the standard workflow. But if your task or some of your something you're trying to code, it takes longer than 5 minutes or 10 minutes, and it has like a many parallel invocation or execution, then you basically take the express workflow path. So those are two differences. Generally, we have seen standard workflow being used in IT automation, machine learning model, because those takes more time to finish. And then in express workflow, we have seen if in case of IoT, we have seen like you send an event, like multiple events are coming to the step function at once, and then step function basically invokes multiple state machines at the same time. So that's basically two parts: is standard workflow and express workflows.
Isn't there an execution timeout?
Yeah. So express workflow has I think 5 minutes of execution of time, and standard workflow can execute as much as one. I think it's more than a year. You can keep your state machine active. So that's different.
I think the high volume data piece is one of the significant differences.
Yeah, that's
for
right.
IoT data,
Yeah.
et cetera.
Because I think standard workflow, it's hard to invoke parallel, like multiple state machine in parallel at the same time. With express workflow, you can, I think it's more than 5,000 you can invoke at the same time, all of the state machines. So that's the difference. I think we'll take some questions and then I'll move to demos. Any questions, guys?
So what's the difference between EventBridge and something like Kafka? I know there's Kinesis, but how is it different? Because Kafka is used to broadcast messages to several downstream at once, and there are some semantics that are possible, like exactly once or at least once, things like that. So I'm just wondering, how is this different? Is there more customization?
Yeah, well, we can follow up with you too and get some specifics, but like in EventBridge, some of the differentiators are, Sas integration, So it's out of the box integration with other SaaS providers. And on the source side, and then on the target side, integration with AWS services. In terms of topics and message throughput and all that kind of stuff, we can get back to you. I don't know those details off the head.
Yeah, I'm just mostly curious about,
Right.
there's Kinesis, there's EventBridge, probably there's some different.
Yeah.
I think I get it.
Okay, cool. Any other questions? From the chat?
Nothing in the chat.
Okay, cool. Okay, then I'll.
Oh, one other thing about EventBridge we haven't mentioned. It wasn't on the slide. I meant to add it in there. EventBridge has this notion of a schema repository. So that JSON structure of the event, your applications can query that and then understand what is the actual message that's being sent through. So that's one differentiator between some of the other tooling that you mentioned.
And I think one of the major differences, you get easy connectivity with different AWS service.
Yeah.
You don't have to basically write the whole code or anything of those sort. Just click and play and you connect it.
Nice.
And serverless.
Yeah. Okay, so I will quickly move to demo. Ask me the authenticate. So what I'm going to show you in demo is pretty quick. I'll create a step function on flag. So what that step function will do is it will do two things. One is it will take an ID card, could be your driving license or it could be your passport, then recognize if that's a valid ID or not by recognizing the photo. So I'm going to be calling Amazon recognize into that. Then once it recognizes like, hey, it's a valid ID, then I'm going to be calling Amazon text extract service to basically extract the text from the driving license and push it into DynamoDB. So what I want to show you here is how quickly you can build the application of the level and how can you basically integrate those multiple pieces together and how you can run it together. So that's the goal of the whole demo. I think what's the time? 6:33. I should be able to cover it. Yeah, sometimes it takes time. Okay, cool. So this is a step function. So you're seeing on my screen a visual studio, not a visual workflow studio. It consists of three parts. So one part is basically all of your services. So with step function, you can have more than 200 plus services. You can have Lambda, SNS, ECS, Glue, all of the SDKs which AWS provides in terms of running an EC2 machine or getting the data from EC2 machine, S3, all of those, right? That's one thing you see here. Another thing is the flow. So it's what we were seeing in the presentation, right? Running in parallel or a choice flow or a pass state where you can just transform your input and then pass it to the next state, right? The wait state, like if you want to wait for certain action to get finished and reply back, that can be done here. Those are the flows. The middle part is basically your canvas to basically build all of this flow. You can just drag and drop the things here and it will work. So let me drag and drop a Lambda function here and it works here. Now the right hand part is basically your configuration piece, where you configure like, okay, hey, what kind of Lambda I'm calling here? What is the input to the Lambda? What is the output to the Lambda? How I'm managing the errors, which I was talking to you before, right? You don't have to write error handling into your Lambda function. You can just handle the errors here directly. Retry errors or catch error, or if you want to do an exponential timeout, or all of those kinds of things are mentioned here, right? So that's a brief about the third navigation piece. Now what we're going to do is I'm going to call this Lambda function, which is basically doing my first task is running an Amazon recognize to identify if the ID or image I'm putting it have face in it or not, just to identify that, right? So I already have a Lambda function created here. I'm going to be choosing it from here. Just face detection.
Zoom in 100.
Yeah, sure.
This next too.
Or now, it's better.
There's a way I can make it full screen here too, but I can't remember. There we go.
It's better now.
There we go. Yeah.
Yeah, you can remove that, yeah.
Not one that let me on.
Yeah, cool. So I'm calling this Lambda function here. The payload is whatever is coming from up. Next state is end. Then I'm just gonna configure the output, what it sends me. So I have multiple ways to basically transform my output. I can do using result selector. This is all JSON path, so it's nothing like something unique it's doing here or something new technology or rocket science is doing here. Everything is JSON. You are just playing with a JSON object here. Either you can use, and the language which you use here is a JSON path to break that whole input or output to according to your state. So what I'm going to do is I'm going to just add the optional input, which is coming from my top to whatever is my Lambda is giving me back. So I'm just going to take my cheat sheet here, just to take the variable name. That variable name is this. I'm going to just put it here. That basically adds whatever my recognition is giving me back into my original input. That's one thing. Now, next thing, what I'm going to do is I'm going to call SNS, which basically doing a task for me is if there is any error, it basically informs my user like, hey, there is an error, or recognition is not able to recognize the image. Or if I want to inform my actual user who is uploading the image, I can do that here. I'm going to choose a topic here. So here you choose a topic. Why it's not choosing the topic here? Just enter the topic here and here. Might lock me off.
No, kick your
Yeah,
ass.
that's the reason. Yeah, why it's not choosing the topic here. Testing. I'll do it quickly again. Upload this. Fine. Just wanna move this here.
Yes, it doesn't say that here.
No, it's not. So just have a topic created where I'm dropping a message. So I bring it here. So now what state machine is doing is starting the process. It's invoking my Lambda and then it's calling an SNS. But the reason I wanna call SNS is to send the error, right? So what I'm gonna do here is I'm gonna make my state machine call go to end here. Says go to end. And then I'm gonna configure the error mechanism here. So I'll go here, I do an error handling, and I do an add new catcher, and I can put the errors here. So you can define your own errors, or you can even use the inbuilt error, whatever is coming from here. It depends upon your need, how you wanna code the error mechanism. So what I'm gonna do is I'm gonna code some inbuilt errors, which I already have. So photo does not meet requirement here. I just enter that. Then I'm going to also enter invalid S3 object exception. So in case the image is not in the format I need, so it's just going to throw me an error, right?
So Lambda will respond with those two messages if it errors.
Yes, that's correct. Okay. So Lambda responds to those two messages and then I take it, right? So here I'll just do text. So if you look at my state machine, it's now like start. I invoke my Lambda function, which is my recognition running there. And then in case of an error, I just catch the error and send the error back to my email or wherever topic you configure on the SNS side, right? What we'll do is we'll quickly save this. Next. Now you can see that it generated a code for me here, which we call it as Amazon state language. So you can if you want to write by yourself, you can write by yourself and it will do this for you. Or if you want to just generate a visual workflow, you can do the way I did just now. But there's another way to write is this Amazon state language. It takes the input, output, and catching parameter. It's based in JSON format, and you can even write in this way here. So that's one way. Now I'm gonna discard. I'm gonna click next, and I'm gonna name this machine as, let's say, identity verification. Now I can create a new role. The reason you're creating a new role here is basically you are assigning the permission for this state machine to call multiple services, depending upon your need, or you can choose an existing role. So I already have a role created. I'm going to choose that. Where it should be identity verification here. So I choose this role. But in case of scenario, you want to create your own role, you can create it, define permissions here. You can have your logging level. So I can on the logging, and you can also enable the tracing here. Like if you're using an X-ray based service, you can enable tracing and get the dependency of all of your services here, right? So that's one. I'll just go ahead and create a state machine. So this created my state machine. For first execution, what I'm going to do is I'm just going to execute it from here. So I'm going to pass my input here, which is JSON format. So I already have this input created. So what this input is telling is, hey, my user ID is A. Anyway, so this input is telling is my user ID is user A, who is uploading the image. So it's giving the S3 bucket ID where my image is already uploaded, and it's giving the key of the image. What's the name of the image, right? So I start execution, and when I start execution, you can see here how it's executing. So I can click here. I can see what is my step input. This is my input. I can see my output. So let's come here. This is my output. So it ran the service here, and it gave me all the component of that image. That image wears eyeglasses or no, sunglasses or no, what is the gender of that image I'm uploading here, all of those. So everything coming from recognized service. I'm not going to dive deep onto recognize. It's altogether a different topic. Just wanted to show you like how you call it from a step function, Amazon recognized service here. So that's one thing. Now what we're going to do is we're going to edit this state machine and use S3 to call this state machine using EventBridge. That's where we want to show you like how an event-driven architecture works, right? But what I'm going to do is I'm going to use a pass state here, which is basically to transform my input, whatever is coming from my EventBridge, into the input which my Lambda requires. So I'm taking the S3 event, I'm parsing that input in my pass state, and passing that to my Lambda function in order for it to execute or to run, right? So here I'm going to go into output here and then just put it here. I already have it. Here we go. I'll just paste this. So it's telling me like, hey, I only need a user ID, a bucket ID, and a key from whatever event S3 is throwing at me. So that's basically what I'm doing here. And I'm just gonna go and save this, apply and exit. Just click on save anyway. So this is what I've done is I've created a pass state where I'm gonna be configuring the EventBridge now to basically pass the input. As soon as I upload an image into my S3 bucket, it should basically trigger my event state machine to invoke my Lambda and publish it. So let's go to EventBridge now. So this is EventBridge console, which consists of event bus, rules, global endpoints. Also, you have concept in EventBridge called archive, where you can archive or you can replay the old events. So it does give the capability to replay the old events. And then you can also configure your partner event source or API destination. And the other thing is schema, which Jonathan was talking, you can have your schema defined here. So all of your schemas, either it could be AWS schema, or you can even create your own schema if you want to create from an EventBridge perspective. So what I'm going to do is I'm going to just create a rule here, which going to be calling my state machine as soon as file is uploaded into an S3 bucket, right? So I'm going to click on create rule. I'm going to name this like S3 state machine. To find rule with event pattern, click next. So here is basically you define the rule like at what action you want to call this state machine or when this state machine should be triggered from the event. So there could be multiple events coming on that event bus, right? So you basically configure here, either it's an AWS event or partner event or other event. So I can configure here. I can write my pattern here. So what I'm going to do is I'm going to just write a pattern here. I have the pattern already chosen. Here it is. Paste it here. This pattern tells is if someone puts an object into this bucket, call my state machine. So that bucket is basically where someone is uploading the image. And then once someone uploads the image, it automatically triggers my state machine at the back. Want to add it?
You didn't choose AWS service as the event type, right? At the very top.
That's fine. I choose other. That's fine.
Okay.
I can even choose them, but I just choose other. Yeah. Got it. Okay, cool. So I'll do next. Then now here I can select the target. So I'm gonna just say state machine. But here you can choose multiple target like Lambda, API gateway, EC2 or EBS, snapshot, Kinesis, Redshift cluster, SNS, SageMaker, whatever you would like. I think it's more than 15 plus targets here you can choose from. I'm going to choose state machine here. I'm going to say StepFunction. I'm going to choose my state machine, which is what it was. This one. Meetup now.
Let me,
Meetup. Cool. And then I'm just going to create a new rule with next, and create a rule. So this creates my rule here, which is which one was the rule? Yeah, here. So this is a rule. Now what I'm going to do is I'm going to upload an image into an S3 bucket, and let's see how it triggers the state machine. So I have the bucket here, which is called ride sharing. I just click load and files. I have some samples driving license, or this is not going to work. To type here .jpg. JPG. So I have some license sitting here. So let's upload this image. It should fail. Just gonna say add upload. Uploading here. Now let's go to my state machine here. Go to verification here. You see this is running now. It automatically triggered this. It's running here. So this failed because I uploaded a wrong image there. That's how you trigger a state machine using an EventBridge. Any question before I go further? I mean, I've been talking a lot. Any curiosity or anything?
So this example, it should call SNS, right?
Yeah, it should call. I think it didn't call it. I need to see why I didn't catch it.
so why are you publishing to SNS and not back to EventBridge?
The reason I'm publishing to SNS is because, let's say I want to send to multiple emails. EventBridge can't do that. I can use SNS to send. I can have multiple subscribers subscribe to my topic and take the message from each other. So SNS is more of you calling your services at the back end, right? You can use EventBridge if you want to have that kind of architecture where you're saying, hey, as soon as it fails, you basically pass event to a EventBridge and call another system to take action on it or to perform some something on it, right? So you can use EventBridge here, depending on your. Yeah, cool.
more question.
Yeah.
Do we see every single event here, or is it just?
Yeah, you see every single event here. So I can go here and I can see, oh, you want to see the event a lot?
I was just curious if it's something heavy volume, like million requests per second or something.
Yeah, it will show everything.
Oh,
Yeah, it shows everything. And all the event goes to Cloudwatch log, so you can always link Cloudwatch to this. And you can even enable X-ray. Yeah, cool. I think last thing what I'll do is I'll just create another Lambda function here. The reason it didn't go because I didn't configure it properly.
Right.
Yeah. I didn't configure it correctly.
Just another question.
Yeah.
So in your example, you have Lambda calling recognition.
Yeah.
But you could conceivably at least call recognition directly in this, right?
Yeah, I can call it. The reason I'm calling it there because I have some checks and balances there to check what my recognition service is replying back. I can get into that now. Actually. This detection. So basically, it's taking some certain variables and checking the length. So I have some if and else logic here, that's the reason I call it. But I can directly go and call a recognition service from StepFunction, take that output, call another Lambda function to do operation. But I did everything in Lambda function.
So there's a balance.
Yeah, there's balance, yeah. Okay, cool. Now I'll just call this step Lambda to basically should be extract, okay? Here, point. I can add all this, I can add here. Here it should be, I think. I'm gonna configure it. Catcher, not the catcher. I think I did do it to here somewhere you catch the error. I didn't put it that here. That's the reason it's not. Anyway, so now what I'm doing is as soon as I recognize the image, I'm calling another Lambda function to basically call it extract the data from that license or anything, push it into DynamoDB. Everything is done inside this Lambda. But as Jonathan said, I can break that process into two pieces here. Like call extract into Lambda, get the output of that extract, and write a DynamoDB call here directly. So I can just say, hey, I want to call DynamoDB here. I want to put an item here. So I can directly do that. But I did it there, but you can break it depending upon your needs. I didn't break it. Okay, cool. Here I already configured it. Exit. Save. I'm gonna just go and upload image here.
So what is the first lambda sending to the second lambda?
So first lambda is sending like, hey, I recognize that image, it has a face. Now second lambda is going and saying, okay, let me extract the data from that license, passport, whatever, I'm pushing it back.
That's a good image, and then you're
Yeah,
using extract to
yeah,
pull out the
yeah.
actual values. That's cool.
Okay. I should have some license here. That's a challenge always.
Or you get your license.
Oh, God, unlimited.
I've used most of the images on one. Okay, here we are. Should be able.
Oh, you from Idaho? Oh, no.
Yeah, I just
Oh,
want
yeah.
Okay, so it pushed, it picked. Now let's go here. Let's go here. Pick. Pick. Yeah, I configured it wrongly.
Did you select the right one?
Yeah, I took the right one, let me check. There's a good enough. So, this is wrong, choose wrong way. Okay, I'll show something which I already have created. So, like that. Yeah, let's take this out. But I didn't do the transform event here properly. It's not appearing properly. I've given it in input state, basically. Function. Should have done it there. Say, go back here to S3.
Copy download.
There it is.
Yeah, I'll just bring the same pane in. Yeah. Back here.
Just doing a demo, you can never find things clearly when you.
Yep, trying.
Do it 1,000 times perfectly until you get on stage.
Different when it's live.
So you can see it's calling my this function. So it passed it, it called my recognize function. So if I look at here, I'll go here and it basically have output generated for me here. Text extract here. So it basically fetched the values, first name, last name, everything from here. Middle name. And I can go into my DynamoDB here and look at it. I go here, go items. I have a table called entity verification. The image was this one. I think. What was the image name?
Samples and then about.
Just fetch what was the image name? Here, 59. This is the image. And it basically fetched address, city and address, class, county, date of birth, date of issue, everything here.
That's cool.
That's cool.
So,
It automatically parsed it.
yeah, I just used extract, extract there. The only thing I'm showing here is how you can call multiple services together using StepFunction. That's the end goal, basically.
Pull it out.
Yeah, any questions, guys?
I probably missed it, but like, how was it like executed? They invoked the step function itself?
Yeah, StepFunction basically goes and solves the matter.
No, hold on.
Yeah.
I think he's asking,
Like,
when the follows up with
Yeah,
this three.
image in S3, there is like a trigger.
Yeah, that's what I configured, like EventBridge.
Configured EventBridge. We added it to the-
I added a rule there saying every time an image comes,
Oh,
go and trigger my state machine. So you see here the put object. Every time I put an image into that bucket, it goes and trigger my state machine.
sorry, that's what I mean.
Yeah. And this basically the first part. This one basically checks if it's a valid image or if it's not a valid image. And then it passes that to TextRack. And then TextRack breaks it and put it in DynamoDB.
And let's say, how would you manage all of this like in source control, let's say? Like through the CDK or?
Yeah, you can write this through CDK or CloudFormation.
How do people do it?
Yeah,
You have Lambda.
So I've seen people doing it with CDK with CloudFormation book.
Because if, let's say, you have like hundreds of them, you cannot like manage that through the console. It's
No,
impossible.
you can manage them using CDK or CloudFormation, yeah, depending upon your need. You can also do using Terraform. Terraform has the capability to write the state machine.
So you create like this infrastructure in code.
Yeah, you
and
can
then
do
you
that,
deploy
like,
it.
yeah, you can, basically what you do is you copy this state language into those cloud formation or CDK, and then it creates for you.
And the
That's-
rules, you need the rules.
Yeah.
Okay.
That you can do. One way I've seen like people writing code to basically call StepFunction SDKs and then creating the whole thing. That could be the other way you can. If you don't want to write this whole state language, then you can call StepFunction SDK, keep on adding the task or configuring the task and do it from there. There is a plugin in Visual Studio Code which you can use to basically code this automatically. So
Or like an extension.
yeah, you have an extension in Visual Studio Code for StepFunction. So you can configure there and then like you can just use CDK or CloudFormation there to basically parse that completely.
And what's the pricing model?
So it depends, the pricing model depends upon the number of invocation, how many number of invocation you are doing. That's one thing. Another thing is, it also depends on the services you're calling inside of it. If I'm calling a Lambda or if I'm calling a text trap, that pricing model is different, right? But the initial pricing model of this step,
What just for the step one?
it's just the number of invocation you're mounting. And the time it's running on the memory, it's
So you
consuming.
bounce on standard on the Go Express. Pricing model.
Yeah, it depends. The question?
Do you call the Amazon recommends?
Yeah. Oh, I call it in this Lambda, yeah.
Can you please show it?
Yeah, sure.
How you call me?
So here, this is the snippet code. I'm taking the bucket ID key, right? And then I'm calling a recognized API called detect face
Oh, straight API.
Yeah. within the language. But I can do this in StepFunction if I want to do.
Oh, you can drag and drop that.
Yeah, I think recognize should be there. Yeah, I can do it drag and drop here. I don't have to write it there. Yeah, the reason I wrote it there is I was wanting to read if and else statement.
Okay, gotcha.
That's the reason I did it.
Showing the pricing page.
Yeah, sure. Yeah.
Yeah, there you go. Yeah. So 4,000 transitions are included as part of the pre-tier, which does not expire after 12 months. And then thereafter, it's 0.025 per 1,000 transitions.
What do you mean by it does not expire, meaning we still get this buffer?
But each step through that is a transition.
Correct.
So the step function you have would be, what, 10 cents?
This one,
Because it's what?
Tell the one that you just built.
or this one?
Times so 3 or 4
Yeah,
steps.
we can calculate using pricing calculator. I mean, it's pretty simple.
Plus the Lambda pricing, et cetera.
And that's a different pricing.
2,500 per 1,000.
Per 1,000, right? Yeah, so it's, I was thinking, I said, that's.
Oh, yeah, for that, that's for 1,000. Yeah, so yeah, for, is that, yeah, that's
Yeah.
pricing represent,
So
yeah.
1,000 executions of that would be.
Yeah.
So I can put here number of execution I'm doing, 1,000. The transition per work to like 4, right? Thing. It's almost 0 because 4,000 is 3 per.
That's right.
Yeah, so like.
Yeah, so 5,000 would be that.
Yeah,
Right.
yeah, 10,000 for you. 0.90 cents.
Wallet breaker.
Yeah, but if you're starting to do like, what you're doing, look at the transactions.
Yeah.
Then.
Seen customer invoking like millions of times per day.
Yeah.
That's tricky.
That's fairly simple stuff.
Yeah. So
Yeah.
I've seen customers using state machine for scenarios like integration with Salesforce and bringing the data into AWS. They use Airflow to basically call the Salesforce API, get the data, use state machines to basically transform that data, whatever they need to transform it, and then move it to S3 or corresponding need wherever they want to move it. Okay, any other questions? I think we are done. We are on time or?
Oh, yeah, we're fine. So
I've got them too.
Or you go ahead.
Oh, Johnson.
That's
That's good, man. They're walking through that.
So this is an example of just using some of our other services. So it's a Lambda function that's going to count the number of customers that are waiting, like this was for a retail type customer. If, and this is obviously very simplified, if there's less than 3, it's going to send a text message. If it's 3, I think I have just equals there, then it's going to make a phone call using our Connect telephony contact center service. And so what it's doing first, though, is there's a Lambda function to query a DynamoDB table to get the customer account coming in from some sort of vision system or other type of system. And so here. And so what I've done is there's 3 rows in the table. So I'm going to start it. And so what that means is the phone should ring in just a second. So let's see. What's up? Just something, it's easy to do that with the UI to just pull in the different services, call a Lambda function, make a choice, and then there you go.
Yeah, I mean, imagine if you want to write this in a code, Java, Python, how much step it's going to take. So simple drag and drop, configure the service error mechanism, and you're done.
The text message aspect would be very handy, especially if you're trying to monitor wait times and such.
Yeah.
Do you see call centers using? Because you have to connect our work.
Yeah.
Connect.
A couple connections.
You got a couple connect things going on right now. Are you guys implementing these things?
They're sort of interested, but we're gonna sort of crawl, walk, run.
Yeah, okay, so it's kind of like after
Right.
you got the main architecture, then that's like a optimization type.
In the example you just showed, what's your trigger there? Just a phone call into the system or?
Well, the concept is using some sort of computer vision service, which we do have, that can do some counts of like people waiting around or things along that nature, and then maybe dump that into something, EventBridge, DynamoDB, whatever, and then do some triggering on it, like maybe every 10 minutes, they want to do a check to see, like, are there too many people waiting in line or that sort of thing? And then call somebody or text somebody based on those types of conditions.
I think Jen has a question saying what is Cloudwatch integration? So state machine integrates automatically with Cloudwatch. So whatever you're seeing in the log all goes to Cloudwatch. So it depends upon you how you want to handle it. Like you want to handle, when I was creating a state machine, there was a log, right? Log enabled. So if I enable those logs, what kind of logs I want to send to Cloudwatch, I can send it from there. The second question is, can you generate the cloud formation from create state function? There's no way like to create direct cloud formation directly from here. You still have to write it, but you do have some plugins in Visual Studio Code which you can use to basically do it for you or to manage most of the tasks for you. If that answers your question.
Yes, thank you.
You mentioned earlier that step functions can actually call EC2 instance.
Yeah,
Is that right? So like you could call like issue commands from a command line in a Linux instance?
Yeah,
From a
you
step
can do that.
function?
Yeah.
Okay. The reason I asked is because one of the bullet points you had was report generation. So just a quick use case, we run weekly reports. And right now we're running, we're using custom Python scripts with Panda libraries, just because the SQL queries can take up to an hour. So that takes Lambda out of the game, right? So we're running custom Python scripts, but we're doing that via EC2 instances. So it'd be nice to be able to, create a state machine to do that, and we could schedule that. Because right now it's just people doing it manually. And then part of the other thing that the Python script does is once it gets the results, that, like I said, it could be up to an hour or even longer. We're using other Python libraries to dump the results into a CSV file in an S3 bucket. And then we trigger, SES from there and things like that. So,
I mean, yeah, it can do it. So that thing is called activity. So we were looking at task. The thing you are asking is called activity.
Right.
Basically, you are writing something into a EC2 and then creating an activity out of it.
Right.
And then calling that activity into a step function. So
Okay.
that can be done. But I don't know about your use case, but have you looked at Glue? Like,
Yeah.
Glue is that thing.
There's an ETL tool
Yeah.
called Glue
okay,
and Glue Studio that may be a better fit.
okay. So is that more for like long running SQL statements?
Yeah, it's more of if you want to generate, like if you're creating a data pipeline or if you're writing data kind of jobs, it has PySpark library there. You can basically call your connector, like, I don't know where you're connecting, it's a JDBC or DBC.
It's a Postgres instance. Then.
Yeah, so you can basically just connect from Glue, do all kind of transformation there and just push it into S3 or wherever you want to push it.
Okay. I'll look
So
into that.
that's another way to do it. And that just told the way, like, I don't know the use case, but
Yeah,
It was something you definitely automated.
yeah.
The manual processing out of that.
yeah,
Absolutely.
that's where like interesting thing happened with me 2 months back, same customer come. They were trying to basically query 3 different systems. One is invoice, one is order, and then one is inventory.
Right.
So they try to create this step function, and I was like, this is not the right case for step function.
Right.
You can solve everything and anything in step function, but this is not the right case.
Yeah.
Like the right case is you do it using Glue, right? Glue will help you out in combining all of the data sources together.
Right. And that's why I knew that the SQL queries are so long, they run so long. I knew that, Lambda was just not feasible.
Yeah.
And when I crossed Lambda off the list for that use case, I crossed off step functions too, but you caught my attention when you said step functions. You can actually execute, command line, command from an EC2 instance.
I think you probably need to look at Systems Manager run command.
Okay.
So is the Python scripts running on the EC2 and you want to trigger that?
Yes.
So then, yeah, step functions can call Systems Manager run command to tell an EC2 machine to execute the Python script.
I see. Okay.
Step function, it's been up your EC2 instance.
Right.
Yeah.
So by itself.
Yeah, you can you need it. Yeah,
That's
true.
Okay.
So yeah, the step functions in EC2 is just the sort of those control plane
Right.
operations.
Okay.
Create, terminate, start, whatever.
Got it.
And then you need something to tell. Maybe you have a cron tab job, so when the machine starts up, it just executes it.
Yeah, so actually similar to what you said, Glue is like a ETL equivalent,
Right.
like you can connect your Postgres.
Right.
Do exactly the same thing what your ETL do on the cloud.
Okay. I'll
Glue
look
is
at
a
it.
better choice than.
Yeah.
All
All right. Thank you.
The other thing, don't see anything question on chat.
I thought it's hour-long running SQL queries.
Yeah,
Yeah.
that's a story for another day. but-
One day at a time. right?
It's very painful.
We used to have a few that we would kick off at night, so that would finish by the time we got in the morning.
Yeah,
I thought every customer does that.
yeah.
Kick off with night and then come in the morning.
Cool. Anybody else got any questions? Well, thanks, guys. I appreciate it. And
Thanks for inviting us.
absolutely.
Sounds good.
All right. Well, if anybody else knows anybody might want to speak at another event, or if anybody in here does, awesome. Always looking for people to lead up an event, or if you got any topics you'd like to hear about, I can see if we've got anybody that we can reach out to. Feel free to reach out to me anytime, but thanks everybody for coming out. I'll try to post the recording and put the link in the comments at some point in time. So. Cool. Thanks, guys. I really appreciate it.
Thank you.
If anybody needs a drink, probably not a beer for the.
Number